Okay, so the first example that we're going to do, and I think this is example 4. Wait, 1, 2, 3, 4. This is example 5. So the first example, this is the first example that we're going to do, which is, kind of the entire 3 steps at once. Okay, so as always, this is a definite integral because I've got bounds here. So my lower bound is root 3 and my upper bound is 2. And the way I like to do definite integrals is first I find the antiderivative of the integrand, and then I evaluate it at the endpoints. So for now, I'm going to just work off of, I'm just going to focus on trying to integrate x squared minus 3, the square root of that, divided by x dx. Okay, so let's see here. So the first thing is I'm looking at this in the numerator, the square root. That's telling me that I want to, when I create my triangle, I want to have that as a leg. So let's see here. So down here, I'll make one leg be the square root of x squared minus 3. And the other leg is going to be square root of 3. And this last, the hypotenuse is x. Now you might be asking yourself, or asking me, Kalila, how did you know what to make each quantity? And kind of let me show you. So here's the idea. So this is kind of in my thought bubble, how I'm thinking about this. Okay, so I know that if I have a triangle, this is A, this is B, this is C. I know that A squared plus B squared is equal to C squared, right? Now, this square root of x squared minus 3, this can't be a hypotenuse because a hypotenuse looks like square root of a squared plus b squared, right? Does that make sense? So since I have x squared, I have square root of x squared minus 3. So because I've got minus 3, it's not going to be a hypotenuse. So this radical is going to be a leg. So I may as well make the leg, the bottom leg. So that's kind of the first step. So I say, okay. So I know in the bottom I'm going to have the square root of x squared minus 3. Now the issue is, what should I make the other leg so that the triangle works out nice and pretty? And uncomplicated, really. So I say, okay, the square root of x squared minus 3 squared plus the other leg squared equals my hypotenuse squared, right? Here's my hypotenuse, and this is my other leg. When I square the square root of x squared minus 3, I'm going to get x squared minus 3 plus something squared equals hypotenuse squared. It'd be perfect if this were equal to 3 so that I could have x squared minus 3 plus 3. Then I'll have x squared equals hypotenuse squared, and I'll just let my hypotenuse be x. So in order to have this squared equal to 3, I need to make the inside square root of 3. So that's how I'm able to say, that should be square root of 3, and my hypotenuse will be x, right? So let's see here. So this thing squared plus that squared is going to give me x squared, okay? And so just practicing different, quantities will make that process go faster for you. All right, so here we are. We've got our triangle. I've got my triangle, and I need to use it to do step 1, which is to rewrite my integral in terms of theta and d theta. Okay, so I'm looking at my triangle, and it turns out that I'll put theta down here at the bottom, and it turns out that cosine of theta is actually my integrand, square root of x squared minus 3 over x. So that was easy because that was nice and lovely. So that means that my integrand here, this is going to be cosine of theta. Now I just need to figure out what is dx. In order to find dx, I need a relationship between x and theta that is as simple as possible. So I'm going to use If I just use this, the square root of 3 and the x, that'll give me a very simple relationship between theta and x. Okay, so I can use, what is that? Opposite over adjacent is going to be, no, opposite over hypotenuse. That is going to be, opposite over hypotenuse is going to be sine of theta. And for us, that's going to be square root of 3 over x. So if sine of theta is equal to square root of 3 over x, that means x is equal to square root of 3 over sine of theta. And another way to say that is x equals square root of 3 cosecant, right? Cosecant theta. Once I know x is equal to square root of 3 cosecant theta, now dx is just going to be square root of 3 negative. Well, now what's the derivative of cosecant? Negative cosecant cotan. So negative cosecant theta, cotan theta, d theta. So this part over here is going to be, the dx turns into negative root 3 cosecant theta, cotangent theta, d theta. So putting it all together here for my step 1, my integral of the square root of x squared minus 3 over x dx is equal to the integral of cosine theta times this negative root 3. Right, so I can put the negative root 3 on the outside. Negative root 3 integral cosine theta. And then I need cosecant theta, cotangent theta, d theta. Okay. And the triangle that I used for that is x theta. Down here I've got x squared minus 3 square root, and over here I've got square root of 3. Okay. I can actually I can simplify this trig integral, so it'll be negative square root of 3 times the integral cosine theta. Cosecant theta is the same as 1 over sine theta. Cotangent theta is the same thing as cosine theta over sine theta. So I actually have negative root 3 integral cosine squared theta over sine squared theta, d theta, which is negative root 3 times the integral of cotangent squared theta, d theta.